I was reminded one more logistic about your guys' test corrections. Just give me a second. Right before I get into L'Hopital's, remind me test corrections, okay? Right before I get into L'Hopital's, remind me test corrections.
What do they do?
Here we go. Number 6, you guys can go ahead and grade. Number 6 was a little weird. True. But what it was just having you do was realize the closer you are to the point of tangency, the better the tangent line approximates. The closer you are to the point of tangency, the better the tangent line approximates. That's all it's having you do. You're using a calculator the whole time, either plugging into the tangent line, which they call capital T, or plugging into the function. This is going to be the exact value. This is the approximate. And they say, hey, at the point of tangency, it's the same. But as soon as you get a little bit off, it's going to be different, but not as different as if you were to get further off. It was just having you experiment and see the further away you get from the tangent line. The further you get away from the tangent line, the more error there's going to be. So you weren't supposed to do it by hand. You weren't supposed to try to think of what ln of 2 was mental math. That's not the point. The point was to plug in these values to the tangent line and to the original function and just compare. And the further away you got from the tangent point, or from the point of tangency, the more error there was. Number 10, this one's a little bit more like one of the ones we did in our example in our notes. Delta y, you were plugging in to your formula that we wrote in the notes, plugging in x and delta x, getting this, plugging in x. Then you were taking those in your calculator, in your calculator, plugging into the function. Because you have to raise 2.01 to the 4th, which you could technically do by 2-column multiplication. But you would go ahead and plug and chug, solve, and you would get negative 0.3224. For dy, you would find the derivative and then plug in, which you could definitely do by hand, and say, hey, how close was it? Not too shabby. 14, just solve for dy using a derivative. Did you kill a bunny? U prime, there should have been a 2. Derivative of cosecant u is negative cosecant u cotangent u times u prime. That's a forever. 2 forevers, technically. Number 28, I believe you were trying to find the mistake, and I know the mistake was that they did not do chain rule. They were missing this 2, I think. They were missing the u prime. The u prime that came from, or came when, you were taking the derivative of the second. You needed negative sign of u times u prime, negative sign of u times u prime. They were missing the 2, and they needed it, so the proper answer would be what's there. Number 36 was a graph and look one. So if you guys don't mind, I'll go ahead and open up the book really quickly. Number 36, I believe, is on the next page. Come on. There he is. He's this guy, right? They tell us that profit is going up in a concave up fashion, and they're asking for whether the change in money, change in profit, will be greater from 400 to 401 or 900 to 901. What'd you guys answer and why? It is 900 to 901. Ashley got it right. Do you have a reason why?
Because the slope is steeper.
Exactly. Yeah. And since the slope is steeper, the rate of change is faster, aka for 1 unit going up, you're going to make more money. It's going to be a higher rise than 1 unit over here would be a lower rise. So yeah, the tangent line indicates. Or you can also say, technically, say concavity. Since the function is concave up, what's happening to the rates? They're getting steeper. But yeah, ultimately this tangent line at 900 is going to be greater than the tangent line at 400, indicating a faster rise in profit per number of units. Okay, questions on odds. Period 1 had a couple questions I still want to talk about. Yeah. 15? 15, got it. I was like 50, I don't think I signed that.
25.
25, yeah, that was one from this morning.
Wait, is 21? 28, sorry.
28. Okay, that was one we just looked at, right? Hold on. 28 was the one we were trying to find the mistake. Let me look at 28 first, really quickly, and if I can find it. There it is. 28, when you go to derive, where's my marker? I don't know, it's missing. It's, what rule do we have to use, guys, when we see x squared times cosine of 2x? I said times, didn't I? Product is the big picture, and then yes, you have a chain within. Let me just go ahead and solve for the derivative quick, because they might have done it in a different order. Oh, don't do that. How about now? Yeah. Okay. So the order that we would do, it is the same order they did. We would say y prime or dy dx is equal to second, d first, which I think they ended up writing this, 2x cosine of 2x. I think that was right. plus, then you would do first, x squared, do second. How do I take the derivative of cosine of u? Negative sine of u times, they didn't do that. They were missing that guy, the 2. So remember, we take the derivative of outside, inside. The derivative of the outside, derivative of cosine is negative sine. Keep the inside of u times u prime. I think that's what. Does that make sense? Okay. Let's go ahead and then go to those 2 odds. I think we had number 15 and 25. You guys are good on 41? Okay, I was going to say, 41, period 1 didn't like. Let's look at number, can we do 41 first, just because I'm on this page, is that okay? Number 41 gives us to approximate the 4th root of 624. Let me zoom in really fast. Zoom, zoom. Hey guys, how did we see in this section, when they want us to approximate especially something with a radical, you know this, what are we going to use, a dy or a tangent line? Uh-oh. Yeah, in class, didn't we approximate square roots with tangent lines? Right? Square root of 26, we approximated. Square root of 1.1, we approximated, 1.01. Right? We use tangent lines to approximate this. So I'm going to use a tangent line to approximate number 41. When we go to approximate number 41, before I forget, Brandon, I'll have yours graded by hours. I had to find, I left it working. Okay, looking at number 41. In order to do a tangent line, what do we need? We need a derivative, but before we need a derivative, we need a function. So looking at this guy, guys, who is our function? Who's f of x? Yeah, the outside part, the root. Okay, what point do you think we're going to be using? What's close to 624 that has a nice perfect form? 625. And 625's 4th root, the reason why we choose 625 is because it's perfectly 5. We don't know 624 yet, but we do know 625. The 4th root of 625 is 5. So we can actually already plug in 625 is our A. We can plug in the 4th root of 625 is 5. Don't we also need the derivative though? And you guys were mentioning we need the derivative. So now that we have a function question, what would our f prime be of the 4th root of x?
1/4.
Good. Rewrite this as x to the 1/4. Bring down the 1/4, and we get x to the negative 3/4. Be nice to your brain. How do we rewrite what that really means?
Square root.
Ooh, careful, not square root.
1/4
4th root of. Now, what derivative am I trying to find? Which derivative? Not just the general. Which derivative do I want?
625.
And some of you are like, how on earth was I supposed to do that by hand? Can't I technically say this is the 4th root of 625 all cubed? I could do the cubed first and then the 4th, or I could do the 4th and then the cubed. They're both part of the power. The nice thing is, hey, what's the 4th root of 625? 5. What's 5 cubed? 125. What's 125 times 4? Well, 4 25s is 100, 400s is 400, 100 is 5. I might have to do a little bit of math showing that, but it is what it is. It wasn't totally impossible, it just took a little bit of mental aerobics. What was the whole point? We have a tangent line. We're trying to approximate when the inside or the x is 624. We're trying to do the 4th root of 624. So where does that 624 go? Inside. So I can say the 4th root of 624, which is f of 624, not 6 point. It's going to be approximated by y of 624, which is, get the y alone, add 5. 5 plus 1 over 500 times 6, why do I keep doing that? 624 minus 625. Some of you are again, how could I do that without a calculator? That's the point, being able to do this by hand. Well, that's going to equal -1. 1 over 500. I was doing some college calculus with Bridget yesterday. She's working on actually this physics thing with work and whatnot, but her professor does not even let them have a scientific calculator. So she has little like 2-column multiplications and additions and divisions all over the place. How do you figure out who 1 over 500 is, the old-fashioned? If I can actually do it right now. It's been a long day. 500. However many you need. 500 goes into 1? Nope. 10? Nope. 100? Nope. 1,000? Yes. 2. 0? 0. Easy. You need to review it, but easy. We end up with 5 plus 0.002 times -1, which is 4.99. Follows very much the pattern of our square root example. Follows very much the pattern of our square root example. Just a little bit funky. And the multiplication and division is a little bit weird. Not quite so mental math. Okay, that was number 41. Let's go ahead and go. Didn't want to do that. Okay, let's go ahead and go peek at number 15 and then 25 respectively, just going in order. 15, I think, and 25 on the previous page, right? Okay. Number 15 gives us. Oh, there was a video. You guys. It's okay. What was confusing about the video? Did they explain it weird? You want to use quotient rule. I mean, I can explain it fast. The video probably would have done a great job too. I think all you're doing is dy, right? So then you guys tell me, how do I find dy? He's like the nicest guy ever. Derive it and then move the x. So if I was doing it really fast, probably won't go quite as slow as the person in the video. You would do bottom, do top, minus top, do bottom, all over bottom squared. Move the dx, because that's the whole point of getting dy. Simplify. Good, we're done. Don't kill a seal. Otherwise you're fine. So you end up with 2x minus 1 minus 2x minus 2. Those cancel. -3 over 2x minus 1 quantity squared d. Don't kill a seal. And do the quotient rule. Number 25. Okay, this guy's weird. Yeah. Number 25, they said approximate f of 1.9 and, guys help me out, f of 2.04. Ooh, let's look at it. 1.9 is approximately, no, that's not what they do. No, they do say something, I think in the directions about using a differential. Forget that, I think that's way too confusing. Let's just use a tangent line. Let's just use a tangent line. Why am I saying tangent line? Hey guys, can't we see an x1, y1 by looking at where the tangent line hits? Cool. So can't I plug in already some stuff of my tangent line? Okay, what can I plug in the y1 spot? How about the x1 spot? 2. How about the slope? Don't you see this kind of seems to hit at 1, 0? Can't I go up 1 over 1 approximately to get to the next point? What's my slope approximately? 1. Ooh, yeah. So how can you approximate? The book would call it something like t of x or something random like that for tangent line. Whatevs, get the y by itself, so I have 1 plus x minus 2, and use it to do what? To approximate him and him. And how do you do that? You plug in the x spot, 1.9, and then you plug in the x spot, 2.04.
Interesting.
There's our thing. That's how tangent lines work, yeah? Tangent lines, you make them and then you use them. For tangent line approximation, I should say. So therefore, I can say f of 1.9 is approximately 1 plus, plug it in, 1.9 minus 2. That's negative 0.1. And 1 plus negative 0.1 is 0.9. If I'm trying to do f of 2.04, I plug in 2.04 minus 2, which will be 0.04. Oh, I'm just plugging in here. So when they plug in your 1.9, that would be a negative, which is why it goes down. Because isn't it going to be a little bit lower on this side? And on that side it goes up. Yeah. But the nice thing is the math of just putting in the tangent line will naturally do it for me. Does that make sense? All right, 15, 25, 41, and, nope, those are the three we did. Oh, and an even, that one, even, 28, whatever. Done. We did 2 extra examples, or 2 extra questions, then period 1, and I think we still have time to get done more examples than they did. You ready? That was 3.7. Let's go L'Hopital's. L'Hopital's. Can I get to the forever card real quick? Just to remind us to review. When do you use the hospital?
When
L'Hopital.
there's fx over gx.
If you can get it, fx over g of x, and if
it has an indeterminate.
when plugging in, you have an indeterminate form. My boys, be nice. Ma'am.
Test questions.
Thank you. Okay, I just passed out the test that I had graded, Brandon, you know why, and I'll give it to you. You can come after school. Okay, test corrections, I said turn them in ASAP. So if you haven't done, cool, get them in the tray today. If you don't, because you're like, ah, okay, we have a quiz tomorrow, which means tomorrow night's homework. Let's have test corrections due at the latest Wednesday. That way you can have it tomorrow night homework, if you can't get it done early. And you'll just have to trust me that I'll get the points into your grade, okay? At this point, we're kind of just going full steam ahead. I think during period 7, I have a lot of things on my list for period 7. My hope was, I updated period 1's grades with everything except for their new chapter, not new, the correct chapter 3A test scores. I'm going to try to update your guys' today as well so you can see where that is. And then you'll just know the corrections will get you a few points. I think that was it for corrections. So, at the latest, Wednesday by the end of the day. Ooh, which means you can work on it in 6th grade. Go team. And during lunch after school. Okay, here we go. L'Hopital. We have to have a limit where we plug in, we get indeterminate, but remember, L'Hopital's only lets us deal with f's over g's. So if it's not a 0 over 0 or infinity over infinity, if it's one of these other ones, they're just going to be indicating, hey, great, indeterminate, I want to use L'Hopital's if I can't use algebra, but I need to get it to look like these two before I can do the rule. And remember the rule says, derive the top, derive the bottom, not quotient rule. That's not what we're doing. Derive the top, derive the bottom, go, limit, and you keep on doing L'Hopital's until it's not indeterminate anymore. So we did some examples on Friday. You guys were having some fun with it, yeah? Because we had old and we had new. Maybe the old was faster. I think in the degree test it was. But in the new, sometimes it's faster too. Then we went ahead and got to this example. Ah! How many times did we get indeterminates? 3. How many L'Hopital's did we do? No, just 3. You only did 3 L'Hopital's because you can only do L'Hopital's as long as you have indeterminate. As soon as you stop having indeterminate, well, that's your answer in some way, shape, or form. What if this was a 0 over 6? Is that indeterminate?
No.
It'd be 0. What if it was 1 over 0? Is that indeterminate? No, it'd be infinite. Check the sign. The only time you can do L'Hopital's is when you have a 0 over 0 or infinity over infinity. So if it was 0 over 6, that would have just been 0. If it's 1 over 0, that would be infinite. 1 over 6, whatever, it's 1 over 6. We ended on this example and we didn't get to finish, but we did say L'Hopital's. Wait a minute, why didn't we just stop here? How'd I get there? Why'd I get there?
Oh, combine it.
This is indeterminate. I don't know what that is. Depends on who's stronger, right? So then I combine by, exactly. Common denominators. And why did I combine? Because what did I want? A 0 over a 0 or infinity over infinity. Well, now say I have an F, I have a G. What am I going to do for L'Hopital's? Take derivative top, derivative bottom. Go, go, go. I can do it fast. Go, go, go. Derive the top, derive the bottom. Product rule bottom.
This might be a dumb question.
Nah, go.
How do you check the sign again?
For infinity, depends on where you're going. If you have a number over 0, if you have the degree of the top winning as you're taking a limit to infinity, you would basically imagine plugging in a huge positive and say it's going to be positive or negative. If you're going to negative infinity, plug in a huge negative and imagine. If you're coming in towards, say, a 0 and you get a number over 0 which shows infinite, you have to check a little bit below 0, a little bit above, and see if they agree. They disagree. Yeah.
Got it.
Did you derive the original equation to
Not
get 1
yet.
over 0 minus 1?
Oh, I plugged in.
Oh, okay.
And that's how, and then I plugged in. And then 1 over 0, 1 over 0 are both infinite. If I was to go towards sine, let's see how to do it. Maybe I want to go into one set of limits right now. We'll just say they're both infinite for right now. We might get back to one set of limits when we're studying for our final. Okay. You guys are taking the derivative top and the bottom, yeah? All right, Issa, come on. We're on section 7.7. Look at it. When you derive the top, derivative of x is just 1. Derivative of sine? Cosine. Product rule. Second? D first. Plus first. Okay. It's time to plug in. Cosine is 0.
0.
It's what? 1 minus 1?
1 on the bottom. It's just 0.
Denominator, what's sine of 0?
Oh, yeah.
0. What's 0 times cosine of 0, which is 1? What does that mean? Yeah, you can clap. We gotta go again. Somebody might be losing faith, saying this just looks gross, so I think it's not going to work. But pause. Have a little faith. It's indeterminate. L'Hopital should work. Derivative of 1 is 0. Derivative of negative cosine is? Bottom. What's the derivative of sine? Of x? What do I have to do when I get to going to this derivative? I know, you can groan, but then start driving. You can groan, but then shake it off, start driving. You know what to do. Second D first, so cosine times 1, right? Plus x times negative sine. Plug in. 0. Don't be defeatist. See what happens. What's cosine of 0? 1. What's cosine of 0? 1. What's 0 times anything? Ooh. Final answer. Don't you dare do L'Hopital's again. You're done. Yeah? Yeah? Okay.
On the homework, are there going to be questions where we can't use L'Hopital's for? Or is it all going to be L'Hopital's?
I guess if they were really mean, they could have one where you plug in right away and it's a number. But is that really mean or is that nice? Should you be plugging in anything? You should be plugging in anything, right? Most of them should be. Most of them.
Tomorrow's quiz won't have L'Hopital's, right?
Don't you want to have L'Hopital?
In there?
Was it L'Hopital or
Because it's easy.
I wanted to have L'Hopital. I'd rather have
Tomorrow's quiz is going to have optimization,
Or
differential, settlement, tangent, and approximation.
Oh, no, this is
It's going to be like, how long is it?
Oh, not crazy. We're gonna go over homework questions first. We're gonna go over homework questions first. Yeah.
There won't be any error propagation.
No error propagation. Good question.
Oh, there's no review assignment, right?
No reviews. Let's just get through all your homeworks and you should be ready to go. We're gonna go ahead and plug in because we want to get past period 1. Is there a question on this? Okay. So then as we go ahead and plug in, we end up with 1 plus 1 over infinity to the infinity.
That's ugly. That's ugly. Isn't just.
Who wins, top or bottom?
Bottom.
Bottom. That means this is going to,
Yeah.
this is 1 to the infinity then. 1 plus 0 is 1, 1 to the infinity. That's 1, right?
No.
Because you're indeterminate. It's indeterminate.
We need to get a common.
Okay, common denominator.
What is that face?
What is that face? Come on, you're feeling it, Sonny. Okay, multiply by x over x. Plug in.
Instead of 1 plus infinity over.
Infinity over infinity to the infinity.
That doesn't work.
Because you don't know what infinity over infinity is to raise it to the infinity. So you ready? Okay, here's what I want you guys to do. I want you to say, let y equals x plus 1 over x. And I'm trying to find the limit as x goes to infinity of y. True?
Yes.
Question. Now that I have 2 sides, what can I do?
You take the derivative of both sides.
You check from both sides?
What is going on?
Wait,
Oh,
Can't I take an ln?
oh no. That's
What the heck?
So x everything was going fine. I don't even know what just happened. Why did you just throw that in
I
there?
threw in limits on both sides because we have to find the limit. But then I was like, if we throw in an ln, that'd be nice. And the nice thing with limits is that we learned a composition. You could pull the composition out or put it back in, which means I can do the following. I can bring down the x because there's an ln in there.
Oh, we like that.
But I had to do an ln to both sides, hence why I had to write the function as a y equals. This is the only time something crazy like this happens, is when you have something to the infinity or to the 0 that you can't deal with. You're going to have to get an ln in there and hold it down.
And you can subtract it. Can you subtract it?
Okay, now here's what gets a little weird. You ready? If I was to plug in right now, I'd have infinity times, well, ln of
That's infinity.
1 is 0. 0 times infinity is still indeterminate. But what if I was to rewrite this and be super snazzy and say, you know what, multiplying by a number is the same thing as dividing by its reciprocal. Multiplying by a number is the same thing as dividing by its reciprocal. Same thing as dividing by a number is like multiplying by its reciprocal. So instead of saying times x, this is really helpful for me. You can say divided by 1 over x. It'll work. Why'd I do that? Because I can now say, hey, if I plug in infinity, infinity over infinity degrees are tied, that's 1, ln of 1 is 0. And what's 1 over infinity? 0. Ha-ha! Lumpy cows. Took me a while, but I got it. Exactly!
We have to do product with the bottom. I do quotient. Bottom.
Just so
Well, I mean, kind of. It's negative 1 over x squared. Right? Oh, this is lumpy cows. I'll go blue. Derivative of the top. Ugh,
One.
that's kind of gross.
Isn't it just the reciprocal of that?
Do you guys like the, do you like writing it? Someone said we could write it as a difference, right?
yeah.
You guys weren't wrong. That might be easier to derive if you write with the difference property. Because then we can say derivative of the top would be 1 over x plus 1, 1 over u times u prime, and then 1 over x, got it. And then derivative would be negative 1 over x squared. Which would be 1 over infinity would be 0, 0 minus 0 over 0. Is this going to be impossible?
Yeah.
What does it go again? That'd be negative 1 over x plus 1 quantity squared plus 1 over x squared all over negative 2 all over x cubed. Does that seem to be going well?
No.
Okay, here's the reason why. The derivatives were easy when we did that difference property. But here's the deal. You're never going to get to the right answer. Go in the easy one. Oh, life lesson. As we finish off class, I'm going to keep it recording. I'm going to finish solving. I'm doing this one just in case it shows up in homework. I actually don't remember. It is the hardest type that you'll see. Which is why some people just say, hey, let's memorize what it ends up being. But the kids, that's the other that one, all the powers are going to keep on getting worse, so it's going to be 0, 0, 0, 0, 0. So like, let me go back and try not to.
Really think you get to be?
Yeah.
No, this man is a god.
I would
He's a god.
Aren't they thinking?
Are you serious? I guess too.
How long if you have someone tutoring you outside of school like in one day? I don't want to.
Like if I'm talking, like if I go to like a fair or we're doing stuff, we're there for like 2 hours. Are we allowed to do that?
We already got like 5 hours up.
We haven't even gone with the picture.
You have to have.
We have to fill out a form.
What form?
You have to fill out the form with a picture.
Okay. We have a picture, took a picture that night.
That'll work.
I only need like one of those 5 hours. You can have the other
Mr.
4.
Williamson,
I only
email
need-
you
we
for
don't
those
forget
7
it.
hours.
You just take on the sheet and you can sign it. I don't mind your signature on it.
So then that's the homework girl doing tomorrow, right?
I try to get on top of your pen.
So we're
Because I've
gonna.
been spot checked. Oh, I can spot check.
Oh yeah, we have to go.
So we're bringing the files.
So let's not get 170.
All references spot checked.
Poor thing, James, they got
James got 100, they got 300 something % yield.
That was for we did target lab. They got 328% yield. They got negative
You got
points.
178% yield, and she takes whatever your percent yield is minus 100, like how much over 100 it is or how much under 100 it is. And since ours was 78 over.
We got a
You guys
22.
have a nice time, the derivative test.
Well, you got 300 though.
See, I won't
No,
be able
James
to.
and
I
Alan
won't
did.
be-
No, you just memorized
So they
the
got-
answer, like she said.
Negative points. But we can redo it.
They're great.
We can redo one, dude.
Yeah.
I'm writing my stuff here.
Wait, Missy, so you're gonna put in 2B and everything today, right?
It's a way of defining E. One way of defining E.
I have a note.
Grab that one, Kate, even though Maggie's not coming.
Wait, where do we get the?
Oh, I need to go check in with Johnson.